You know that feeling, right? You're trying to book a ticket for a super popular bus route, and it's sold out. It is so frustrating. But what if I told you that behind the scenes, there's this surprisingly simple, really elegant piece of code working to make that whole thing fair and organized? Well, today we're going to pull back the curtain and see how a basic data structure, the queue, solves this exact problem we've all faced.
Okay, so here's what we've got on top. We'll start with the booking problem itself. Then, we'll introduce the solution, the queue. We'll see it all in action, connect it to the world of electronics, and wrap up by looking at where else these data structures pop up in our world. Let's get into it. All right, section 1, the booking problem. Let's set the stage with a situation that's probably all too familiar. So just imagine this. You're at a packed bus station. Everyone's trying to get a ticket for the last bus out. And then you hear those dreaded words. Sorry, we're full. So what happens then? Does it just become a total free-for-all, or is there a fair, organized way to handle it? That right there, that's the problem we're tackling. And here's where it gets tricky, because it's not just about one bus, right? You've got tons of different routes. You have to track a fixed number of seats, say 30 per bus. And most importantly, this is the real kicker, you have to handle bookings, cancellations, and a waiting list in a way that's completely fair. It's a lot to juggle. So how in the world do you bring order to that potential chaos? Well, it turns out computer science has this awesome, super elegant solution. Let's talk about it. Meet the hero of our story, the queue. And its superpower is simple: fairness. It all comes down to a principle called first in, first out, or FIFO for short. Think about it. It's just like standing in line at a coffee shop. The first person to get in line is the first person who gets their coffee. It's simple, it's effective, and everybody understands it's fair. I mean, look at the difference here. On the left, you've got pure chaos. It's a total mess, and it's not fair at all. But on the right, you've got calm, predictable order. That's what the queue brings to the table. It's literally the difference between a mosh pit and an orderly line. Okay, so in the world of code, these two main actions have special names. When a new person gets in line, they go to the back, right? That's called NQ. And when it's your turn at the front and you get served, you leave the line, that's called DQ. NQ to get in, DQ to get out. Simple as that. All right, enough theory. Let's see how this all comes together to build a real working system. We're going to walk through what this looks like from start to finish. So here's our bus. In the code, we represent this as a simple array. Think of this grid as the bus layout. Each little square is a seat, and since they're all green, it means we've got an empty bus. All 30 seats are up for grabs. Okay, now people start booking their tickets. Watch this. The system finds a green seat, marks it as booked, and flips it to red. And this happens in real time. With every single booking, our array gets updated instantly. And then it happens. The last seat gets taken. Every square is red. The bus is totally full. So is the next person out of luck? Not at all. This is where our queue shines. The system just adds them to the waiting list. It enqueues them, and now they're officially the first person in line for an open seat. Now, check this out. This is the really cool part. Someone cancels their ticket. A seat flips from red back to green. So what happens? The system doesn't even blink. It immediately looks at our queue, finds the first person waiting, dequeues them, and boom, the seat is theirs. It's all automatic, it's perfectly fair, and that is first in, first out, doing its job beautifully. Okay, so this whole idea of an orderly line isn't just for booking tickets. Not even close. It's actually a fundamental concept that powers so much of our digital world. All you have to do is switch out passengers for data packets. And the comparison is almost one-to-one. In the bus system, you have a passenger. In electronics, that's a data packet. A bus seat? That's just like a memory slot. And the waiting list we created? Well, that's what's known as a buffer queue. It's the same exact logic, just applied to information instead of people. Yeah, this FIFO logic is basically the secret sauce behind so much of our tech. It's how your computer makes sure the data for a file you're downloading arrives in the right order. It's how the tiny chips inside your gadgets, your phone, your smartwatch, manage information without crashing. And get this, it's literally how your internet router is handling the traffic to stream this to you right now, making sure everything flows smoothly without a digital pileup. All right, let's bring this all home. Now that you know what to look for, you're going to start seeing this simple but powerful idea everywhere. Seriously, once you see it, you can't unsee it.
Queues are running airline and train reservations. They're the reason your print jobs come out one after another, not all jumbled up. They're what's organizing the line when you call customer service. And like we said, they're inside the routers and all sorts of other embedded systems, just quietly keeping our digital world in order.
So what's the big takeaway here? It's that the queue, this really simple concept, is an incredibly powerful tool. It's this elegant, go-to solution for managing any kind of limited resource, from bus seats to data packets. And it does it in a way that's both super efficient and, most importantly, fair. And so I'll leave you with this question to think about. Now that you know the secret, now that you can recognize its signature of fairness and order, where else are you going to see the simple, powerful logic of a queue quietly running things in your world?